In this video, we'll learn about conditional statements or if-else clauses. These allow you to execute one or another block of code depending on a condition that you provide. Before we get into that, I want to just recap where we are. So you'll recall the tennis ball launcher problem where we wanted to compute the initial speed such that the ball would bounce at a particular location. And we wrote this code. I'm showing it here with line numbers for reference. And the code began with importing the math module, then defining some constants. Then here we translated the initial angle into radians. Here we computed the initial speed. And I've added a couple more lines. This one is for checking that the speed is, say, less than the maximum speed that the launcher can achieve. So that maximum speed, I've defined it to be 20. And this is a simple Boolean expression that will evaluate to true or false depending on whether the speed is less or greater than the maximum speed. And it saves the result to this Boolean variable called isValid. And then say we have some function called processResult, and that will take as inputs the initial speed and isValid, and will do something which is unspecified here. Let's notice something about this code. Well, it consists mostly of what I would call assignment statements. Those are statements where you have a right-hand side, which is a value, and we assign that value to a left-hand side, which is a variable name, using the equality symbol. So that's true of lines 4 through 8. It's also true of a line 11, a line 14, and line 17. In line 11 and 14, we have a function that's being called, and that function returns a value which we assign to the variable. Same here. On line 17, we have a simple Boolean expression, and its value is being assigned to a variable. On line 19, we have a simple function call that is not returning any value, so it's not an assignment statement. And on line 1, we have an import statement that essentially imports some functionality into our workspace. Another thing that we can notice is that the execution of this code is sequential or line by line. So the interpreter is going to start at line 1 and it's going to go linearly through all of the code until it reaches line 19. So that's something like this, just a linear execution of each of the lines of code. What we're going to see now is how we can introduce some more complexity into this linear execution so that we can, say, bifurcate the execution using some condition. And if that condition is true, then the interpreter is going to take one path, and if it's false, it's going to take another path. So this is what is known as a conditional statement. Later, we will learn about loops, which is another way of introducing complexity into the execution of code. And in a loop, you take some block of code and you repeat it many times. So between conditional statements and loops, we will have different ways of controlling the flow of the program. Let's look now at an example of the use of conditional statements. This diagram shows the algorithm that a police officer may go through when they make a traffic stop. They start with some information that might consist of the speed limit. This would be a float. The speed that the person was traveling at, that would be also a float. And whether they have a license. This would be a Boolean. And first they may consider whether the speed that they were traveling at was greater than the speed limit. If that is true, the person was speeding. And in that case, depending on whether they have a license or not, the person may get a speeding ticket. And if they don't have a license and they were speeding, let's say they get arrested. Uh, on the contrary, if they were not speeding, the speed is not greater than the speed limit, well, then the police officer may ask themselves, well, were they going at a speed that's less than zero, at a negative speed? If that is true, then they'll have some questions for the driver. And if that is false, then they were traveling at a legal speed, and the answer is to do nothing. We're going to implement this diagram in Python. And these bifurcation nodes, we are going to implement using conditional statements. So let's see the syntax for doing that. An if-else statement or a conditional statement implements a bifurcation in the program flow. Now that bifurcation is going to be controlled by a Boolean expression that when it evaluates to true, we will execute code block 1, and when it evaluates to false, we execute code block 2. Now this branch is actually optional. We don't actually have to include a false condition. So here's the syntax for implementing this in Python. We begin with an if keyword, and then that is followed by the Boolean expression. This Boolean expression, it could be a simple Boolean expression, it could be a compound Boolean expression, it could even just be a Boolean variable. So anything that evaluates to true or false. And then we follow that with a colon. After the colon, we have to leave an indentation, and then comes code block 1. That is the code that is executed in the case that the Boolean expression evaluates to true. This code block, it could consist of many lines of code. So it could be, there's no limit to how many lines of code you include in a block. And then, as I said, the false branch is optional, but if you have a false branch, then you indicate that with the else keyword, and then another colon, and indented, we have the code block for the false branch. Okay, here we are in Python, and we're going to implement this diagram. I have defined already the constant speed limit, speed, and has license, and just given them some values. And the first thing that we encounter is this conditional. So let's implement that. Remember our syntax. First we put the if keyword, then the Boolean expression, which is speed greater than speed limit, and then a colon, and then press enter. Now the program Jupyter Lab is smart enough to know that we need an indentation, so it adds it there automatically. So now we are implementing code block 1, which is everything along the true branch. I'm not going to implement that yet. Let's just leave that as a comment. So code block 1. And then along the false branch, if we want to implement that, we just say else, colon, and then enter, and then this is going to be code block 2, where code block 2 is all of this. Okay, let's go back and implement code block 1. Code block 1 has, it begins with a conditional statement. So this one is going to say if, and in this case, the expression is simply a Boolean variable called has license. Colon, enter, and so now we have to implement the true branch, which says speeding ticket. I'm just going to print here, you get a ticket. And for the false branch, we say else, and then print, you are under arrest. Okay, so that takes care of this. Now let's go to code block 2, which was this conditional. So the condition here is speed less than 0. And we put a colon, and then we have, if that is true, say print, I have a few questions for you. And then if that is false, then do nothing. I'm just going to say, have a nice day. Okay, and that's it. That is the implementation of this diagram in Python. So let's see if this works. Here we have some values. If the speed limit is 65 and they were going 68, but they have a license, then we would expect that we will end up here in getting a speeding ticket. So let's evaluate that. You get a ticket. What if they did not have a license? Then we would expect that it ends up in the arrest block. So if I change this to false, now I should remember that I have to execute this block again, the first block, execute that again, and then I can execute my code. You are under arrest. That is correct. One of the details that I had not mentioned about conditional statements is the use of the elif keyword. So elifs can be used to create this sort of a cascade of conditions where we can start by evaluating B1, and if it is true, then we execute code block 1. But if it is false, then we go to a second condition, B2, and if that is true, we evaluate code block 2, and if it is false, we go on to a third and a fourth and so forth. And we can have as many of these blocks in the cascade as we want to. Well, let's see an example of why this might be useful. Okay, so here we have the temperature outside measured in degrees centigrade, and we want to print an exclamation about the temperature depending on its value. So if the temperature is over here, then we want to say it's freezing. If it's less than 0, if it's between 0 and 10, we want to say it's cold. If it's between 10 and 20, say it's mild. If it's between 20 and 30, warm, 30 and 40, hot. And if it's greater than 40, we want to say ouch. Okay, so here's some code that could do that using if and else. If the temperature is less than 0, print freezing. Okay, that takes care of all of the values of temperature that could be in this region. Else, that means if the temperature is anywhere here, then the next thing we're going to do is check if it's less than 10. So if it's on this side but less than 10, then it is definitely in the cold region and we print cold. But if it is not less than 10, then it must be greater than 10. So we can bring this over here, and we're in this clause. Now, if it is less than 20, then it must be between 10 and 20, and we print mild. But if it is not less than 20, then it must be over here. And then we check if it's less than 30, and if it's between 20 and 30, we print warm, and so forth. And what we end up with here is a code that is a little bit difficult to follow because we are increasing the indent level with every clause here. So this is a good application for the elif keyword. With elif, we can convert that code into this code, which is a lot nicer. Basically, what we're doing is we are eliminating the else, and we're bringing this if up here, then eliminating the SE of the else and bringing this if here, and so forth. That's the editing that gets us from this to this. So the way this reads is, if the temperature is less than 0, print freezing. Otherwise, elif you can read as otherwise. If the temperature is less than 10, print cold. Otherwise, if the temperature is less than 20, print mild. Okay, so that's going to work because say the temperature is 15, then that would fall into this clause here, because this is the only one where this expression is true while all of the previous ones are false. Just as before, the else is optional. In this case, we include the else in order to capture all of the temperatures that are above 40, and we print ouch. Okay, so really this elif is just a nicety, we call it syntactic sugar, to make code that might be ugly and difficult to follow into something much nicer. So that's elif.